Hi everyone. So to continue with Chapter 8 and Origin of the Solar System, we are going to continue talking about the characteristics that we know of the solar system that we have seen already in our course. And then we're going to take all these characteristics and look at them in terms of theories about the origin of the solar system. And these are just theories, but they need to address all the characteristics and all the observations that we know of the solar system. So let's explore that a little bit more. What we're doing now is we are looking at the fact that there are four things that we know about the solar system. We know that our solar system is in the shape of a disk, and that disk has an ecliptic, which is a plane on which all the planets of the solar system revolve around the sun. And we know that the planets basically have a common rotational pattern of counterclockwise and have a common revolutionary pattern of counterclockwise around the sun as well. Of course, Venus always throws a wrench into that, but we'll come back to that. We know that there are two planetary types, terrestrial and Jovian, which is the smaller planets and the larger planets. We've discussed that a bit. And we're going to learn a little bit more about space debris, which is an observation and a characteristic of our solar system. And we're going to learn about what we know about the age of our solar system based on different areas that we've surveyed, and they all seem to come up with the same answer. So let's go into a little bit more specifics, and then we'll go into the theories that address all of these common observations. So that common disk shape. This is the fact that we know that the sun is in the center of our solar system, and we have an ecliptic, a common plane where all the planets, all 8 planets, seem to be very close to this plane, less than 8 degrees difference in each planet's orbit around the sun and the angle at which they take that orbit around the sun. So we've got this very familiar ecliptic shape that is very characteristic of our solar system. And not only that, but the rotation and the revolution are standard among the planets, with the exception of Venus, which we'll get back to. To go over briefly the planetary types, we've gone over this before. We have the smaller, rockier planets with a few moons, and we have the larger gaseous planets with many rings and many moons. So we have these two sets of very different planet groups in our solar system. And we have to explain that with a theory of their origin. Let's get into a bit more about space debris in the inner solar system, which is around the terrestrial planets, and the outer solar system, which is around the Jovian planets. So we're talking about asteroids, meteors, comets, dwarf planets, lots of space debris. Let's get into that. When we talk about the inner solar system and the terrestrial planets, we are often hearing about the asteroid belt. And you get the impression from science fiction movies that the asteroid belt is an absolutely deadly place to find yourself in if you are trying to get to Mars. And it'll probably destroy your spaceship. And that's very dramatic. And the fact is that asteroids are rocks, and they do have an orbit, but they're smaller rocks, much smaller than a planet. They are not spherical. They are very oddly shaped, and these rocks tend to hang out in the asteroid belt, and meteoroids are smaller rocks. Meteoroids are small rocks that hang out in the asteroid belt as well, with the larger asteroid rocks. All of these orbit. Sometimes the asteroids actually have their own small moons. Amazing to think about, right? But if you think that the asteroid belt is this dramatically treacherous place that you could never get to Mars through the asteroid belt because you would be pelted by these rocks, that is actually not so. The asteroid belt is pretty sparse, and in fact, you've heard plenty of theories, I'm sure, that the asteroid belt is just a failed planet and it should have been a planet that broke apart. Well, the data shows that there's not enough mass in all of the rocks in the asteroid belt to make up any more than 4% of the Earth's moon. So while there are rocks in the asteroid belt, there's not a lot in the way of rocks in the asteroid belt, and we're going to explore a little bit more about why that is. But in the meantime, some of these asteroids are known as minor planets because they have an orbit around the sun. They are not spherical, and they are certainly not clearing out the debris because they are part of the debris, but they're known as minor planets because they do orbit around the sun. We talked about the failed planet theory. There are about 2 of them that are larger than 100 kilometers in diameter. It's about 60 miles. They're hard to track because they are so small in size. Tens of thousands of them are much smaller than that. They tend to be also hard to track because they're very irregular in size. And we will come back to more space debris in just a minute.